Okay. Now it's recording. Okay, cool. So we have our 80,000 Newton per meter spring here. So let us use this opportunity. Callie, talk to us about, for part A, talk to us about the energy. How would you solve part A based on the energy? Yeah, okay, so tell me this. What kind of energy do you start out with? Okay, very good. And at that moment, V0, when the thing just leaves, when the kid just leaves the spring, what kind of energy does that have? Kinetic. And there you go. Thank you for telling us how to do part A. Part A, BES equals KE. And so we have 1/2 KX squared equals 1/2 MV squared. And so we say V is the square root of KX squared over M. Sorry? Well, because they asked for the velocity just as he leaves the spring. So we haven't started going downhill yet. But you're right in that guy does have I don't know, if it's a girl, it's pretty scary. But yeah. Well, is that a terrible statement?
Yeah, I guess.
But, I mean, come on, isn't a 220-pound girl kind of scary?
Yes.
You know, hey, how many guys in here would go out with a girl who's like a head taller than him? See, look at that. I mean, I find it really interesting. What's that?
If I go East Coast, they're all going to be.
Yeah, but what they
Is there going to be a girl? I mean, what are you, like 5'9"? 5'11"? You're going to get a girl who's 6'7"?
Wait, 6?
To be a head taller than you?
Look, because she doesn't shake.
Well,
Yeah, see, that's the thing.
Don't want to date.
See, the interesting thing, how many girls in here would date a guy whose head went to your shoulders?
Well, Swedish supermodels are kind of tall. They're Swedish.
You ain't getting any, man.
It's recording, genius. That was Merlin. Just to be clear, set the record straight.
Oh, let's not put any names into that.
You're so dumb, Merlin.
Give your name and your phone number. All girls who hate Merlin, please. Yeah, but because I asked my wife that, and she's like, "No, I wouldn't even have given you the time of day." Because we were like walking down the street. She was on the sidewalk, and I was on the on the street. Yeah, that's weird. Amazing. All right. Oh, that's still recording too. Okay, cool. It's fine. Whatever. All right. So now, if we want to do this, Keith, what kind of energy do we have as we leave the spring? Okay, good. Do you see if we back up our back up our scope, we see that we have kinetic and potential of gravity right here, right? So then what we have to do this part, let's go with some green. So we have energy initial is going to equal the mechanical energy final plus the work, the non-conservative work. You know what? I'm just going to say, because I'm going to say PES plus PEG, and of course that's going to be PEG1, is going to equal, oops, just kidding, is going to equal E2, because we're going to stop at some point over here, plus mu m g, and then it's like, oh, that's weird. Oh, well, that's fine, whatever. G's in there too. And we're going to do G sine theta. Is that right? No, it's G cos theta. Sorry. MGD cos theta. Because on this incline, like there's a box on the incline, the force of friction, if the box is moving this way, the force of friction is moving that way. And then gravity goes like this. right? So the sum of the forces parallel, right, kind of like are equal to MA. And then that means, and then the sum of the forces is equal to 0. N is equal to Fg cos theta. So friction is mu, right? And then Fn is that. So it's mu mgd cos theta. Do you see why? The force of friction comes from the normal force. Yes? Does this make sense? The force of friction comes from the normal force. It's how hard it's being pushed into the surface. Okay, I'll finish this and post it, so see you tomorrow, we'll continue. Actually, that's pretty much done. We just got to solve for D.
Except for Swedish.
I wonder how much record captured, like how much of the small talk your recorder captures.
I know. That'll be interesting to hear. Well, you guys will be able to find out, right?